I mean, Windows can't even handle the Threadripper 2990WX, at least efficiently. So we're talking Linux workstations. We're gonna build Linus Torvalds' dream workstation. I'll explain more about that. But first I have to unblind myself. That is a seriously impressive system. Although I'm not sure how quiet it is. Not sure. Well, on my desk here, we've basically got a cluster of Threadrippers. 10 gigabit Ethernet interfaces, multiple fans, radiators. Easily consumes over 1,000 watts of electricity. Running benchmarks on all three of these, I have to use a different electrical circuit. 20 amps is not enough. That's how insane this is. So I said this is Linus Torvalds' dream build. What did I mean by that? Linus Torvalds recently commented on a mailing list that, hey, the 2990WX benchmarks are kind of impressive for compiling code and that sort of thing. It's 32 cores on the desktop. It is a seriously high-end processor from AMD. It's new computer science. It's new hardware. I mean, to think just a few years ago, what, 10, 12 cores at the highest end was basically what you could get. And if you wanted something higher than that, you had to go to Xeon, and it was like 18 or 22 cores. Well, now 32 cores, 64 threads is available at the super high end. So I've been doing a lot of building, a lot of system testing, and a lot of general insanity to try to figure out how best to use the 32 core Threadripper monster. It is a crazy CPU. It has a TDP of 250 watts, but if you let it use more power than that with precision boost overdrive, you can get quite a bit more performance out of it, as long as you can manage the heat. And so finding a combination of components that will let me have a really high performance 32 core system for software development tasks, things like running VMs and compiling code and doing the kinds of things that Linus Torvalds wants to do, it's a little tricky to pick the right combination of components because Linus Torvalds has very exacting standards. One, he wants a super, super quiet machine. And so that has gone into the testing, but also a powerhouse machine. Doing the testing with ECC memory, this machine has 128 gigs of 2666 running with really tight timings. The crucial timings are fairly loose at 19, but I've done multiple hours of burn-in testing and I've been able to get the timings down around 15 or so, even with the 128 gig kit. 2666, that does make up quite a bit of performance. G.Skill also has a Threadripper specific memory kit. Now this is not error correcting. Depending on what you're doing, error correcting may or may not be important to you. This is 128 gigs, runs at 2933 out of the box. Tested on the Aorus Extreme and the Gigabyte Designaire. Everything was peaches with both kits of memory. I didn't have any trouble getting 128 gigs of memory to work. And the same can't be said on, some of the other motherboards that I tested, especially early on, especially some of the people on the forum, 128 gigs of memory didn't necessarily work perfectly well out of the box. We're using the Fractal Define R6. That's the component that I settled on for the case. It's a large case, but it's not too large. It's not Steve Giant Coffee Ripper build large. It's large enough. It doesn't need to be, honestly, I don't think you could do a 2990WX in a smaller case and have heat dissipation. Now the Fractal Define R6 gives you some options. This one is configured with a top exhaust, and we can see that we've got our Enermax TR4 cooler in the top, and so it's just exhausting the heat out the front. In this one, we can see that I've got the Enermax TR4 cooler, but it's configured to exhaust out the front. So we'll talk more about the fans in a minute, but I've been through tons of combinations, and these configurations work best. This one will run a little cooler, but it's louder, and it's harder to get to the RAM and other stuff because the radiator's kind of in the way. And there's no option, you have to run the radiator at the outside position. You can run the radiator, there's screw holes that you could run the radiator a little, you're not gonna be able to do that. In this configuration, you've got a ton more room to work inside the case, but you've got to make sure that your fans on the bottom are bringing in adequate cool air. Otherwise, you get into some airflow issues and sort of recirculation issues inside the case. So you've really got to dot your I's and cross your T's when it comes to the fan controller aspect of this. Because this is a 2990WX, I've selected a second gen motherboard. I think that the Designaire motherboard from Gigabyte, while it's technically a first gen motherboard, it is a super high-end first-gen motherboard. It has a dedicated fan for the VRMs. The Aorus Extreme has 2 fans for the VRMs. They've reworked the VRM area. The heat sinks are true heat sinks. They have fins. They're designed for dissipating heat. The heat pipe directly contacts the VRM, and they're using very high efficiency pink thermal pads. Pink is like support for no VRM cancer. Like, it's not gray. People are like, oh my gosh, it's ugly. No, the pink pads are more efficient. The pink pads are fine. Just run with the pink pads. But they thought about it, and they were cognizant enough to say, like, by the way, we tried to get gray thermal pads, but the best thermal pads that we can get right now, the pink ones. So there's pink thermal pads for the VRM area. And the VRM has 2 fans. I mentioned that, but Jesus, 2 fans, that's crazy. I also tried the Meshify C, the Fractal Meshify C. This is a much lower cost option. I've got the Noctua cooler in there. This configuration is insufficient for a 2990WX. Not gonna happen. 2990WX, you're gonna need something like the Threadripper, and even then that's only gonna work at stock. You're gonna need something like the Enermax if you're really gonna let the 2990 stretch its legs. For the 2950 or 1950, you know, Noctua cooling inside the Fractal case, because the Fractal case breathes really well, that can work, but this is significantly louder. So how loud are we talking? This Fractal case gets the quietest at around 25 dB, give or take, when the system is not under load. When it's fully heavily loaded, you know, maxed out, it's gonna be about 27 dB. You know, the Meshify is a little less expensive than the R6. This is a good alternative build, but it is louder. And so this is gonna be like upwards of 40 dB when it's fully under load. We've also got this Fractal Define R6, which is the tempered glass side panel. And with the tempered glass side panel, it's gonna transmit a little bit more of the noise. So I've got the radiator configured in the top, which, you know, it's modular. So you can pop that out and the radiator's mounted here. And this is the first gen TR4 cooler that I had already from last year. So it's like, all right, let's do a head to head. Let's do a side by side and see how these are. This is sort of middle of the road. So this is, you know, not fully loaded. This is around like 32, 36, and fully loaded goes up to like 36, 37. I'm gonna put B-roll on the screen because I'm not 100% sure of my numbers. I should have wrote it down or have a teleprompter or something. Don't have the giant teleprompter yet or anything like that, but this is nice. All right, so what we're working with here is the Enermax TR4 liquid cooler. It's a closed loop all-in-one liquid cooler. It's 2nd generation. There were some manufacturing problems with some, but not all of the 1st gen TR4 coolers. They got a bad rep in my opinion. Enermax will fix them. I really like it. I've put it through the paces. I've done all sorts of terrible things. 2nd gen TR4 cooler from Enermax is awesome, especially if you want a quiet system. It takes a long time for the heat to soak. It's really great. The fans that it comes with will go up to 2300 RPM, which are quite loud. We want to build a quiet system. Noctua is the king of that. Now, I started to go buy some Noctua fans, but it was like, maybe I can use my YouTube powers for evil. So I reached out to Noctua and I said, hey, I'm doing this build. It's sort of a promo kind of thing. Would you send me 6 fans? And they said yes. So I asked for them. They sent them. Thank you, Noctua. It's pretty great. And these are the shockingly quiet fans that are manufactured with super tight tolerances. They're 120 millimeter. They go up to 2000 RPM. They're available in PWM or DC control, or like DC, like 3-pin, 4-pin. Ultra low noise if you want ultra low noise. They're really super amazing. I was blown away. So I've configured this. This is where I've ended up for the quietest operation 2990 tolerant fan configuration. This took a lot of experimentation. So we get the Enermax radiator in the front. It is exhausting out the front. It's not an intake. For the bottom intake, I've got 2 Noctua fans, a 120 and a 140. I tried to get 2 140s in there, but it was just a little bit too tight of a fit with the radiator. And those fans are configured with the highest fan RPM profile. They run from like 1700 RPM to 2000 RPM. By far, those are the loudest fans in the system. And it's just this, I mean, these are, all the 120 millimeter fans are the same in the system except for the 140. And the 140 is also the Noctua. It's the industrial PPC. It's up to 2000 RPM. It's a black Noctua fan, but it's in there and it's bringing air in from the bottom, and then the air comes out the top. So the air comes in from the bottom here. Some of it will go out this fan. This fan is configured for 1700 RPM, and it will ramp to 2000 RPM as we reach the TJ Max of the 2nd gen Threadripper CPUs, which is fairly low, 68 degrees C. And then these 3 fans are all linked together for the exhaust, and they'll also follow that same fan profile. This is plugged into a water pump header, and the water pump header is configured for DC full speed. So you should be seeing about 2000 RPM report on your Enermax cooler. Whenever you do a BIOS update or a BIOS reset or whatever, you will probably have to go into your BIOS and reconfigure it. Your pump otherwise might not be running at the right RPM and might not be cooling the way that it's supposed to. This configuration works awesome for heat dissipation and quietness. Another nice side effect is that these fans do provide enough pressure to push the heat, out the front and in these side vents. But if you're running a 2990, especially with an overclock, we're talking 400 or 500 watts of heat. You can open the front, it'll breathe a little bit better and it'll breathe louder, but it'll work great in terms of extra heat dissipation. Now, the other obvious option is you can put the radiator in the top. Well, guess what? I did that too. I did that with the 2990 and the 2950. That does run cooler than this, but it's also much louder even given the same fan profile. And it's also much louder even if you try to back the fan speeds off a little bit and change the fan configuration. So the configuration I tried was with front intake fans and one bottom intake fan, and then the radiator exhaust in the top plus the exhaust out the back. Now, just sitting on the desk, the system was much louder than it is now, and the thermals weren't that much better. Now, for the storage part of the video, it's a little trickier because I'm not really sure what Linus's preferences are. I've opted to go with 4 960 Pro M.2 drives, and we're running that in a RAID 10. So it's a mirrored striped configuration. In that configuration, I can do over 12 gigabytes per second read and about 5 gigabytes per second write. For chewing through massive IO loads, that actually works really well. I also have a 480 gig Intel Optane PCI Express SSD added into the mix. Maybe the home directory would benefit from Optane, or if 128 gigs of memory isn't enough, we can set up swap on the Optane so that any jobs that we do that won't fit in memory could swap out to Optane and run that. I myself have done jobs with things like RepoSurgeon, where the older versions of RepoSurgeon would need a lot of memory to run, and 120 gigs wasn't enough, but I don't really want to buy a ton of memory because memory is crazy expensive. Let me tell you, for the graphics, we're running a Radeon Pro WX7100. Why the WX7100? 4 DisplayPort outputs, all the pixels you could ever push. It's advanced DisplayPort, runs really well. The card runs relatively cool and quiet. It's also commercial, it's enterprise grade. We've got Vega. The Vega card would be faster, but this card is gonna run hotter and it's gonna be louder. So I opted not to pick Vega, although maybe the Vega Nano, or maybe a Vega that's been modded, or an aftermarket Vega wouldn't be a bad choice, although it's still gonna produce a fair bit of heat at stock voltages, unless you undervolt it. I could flash a custom BIOS. That remains an option, but I would guess that Linus's preference is probably something like the Radeon Pro WX7100. Why the WX7100 versus an NVIDIA counterpart? Well, I think we know why.
NVIDIA, you.
Linus tells it like it is. Oh boy howdy, let me tell you. So you say, sure, you talk a good game, but does this system benchmark really well? I mean, look at it. It's an unassuming black box. Everything else I've seen on YouTube is this RGB monstrosity. Yes, we can compile the Linux kernel. I mean, isn't that the benchmark that matters most? At about 25 to 30 seconds on this monster of a machine. Using Indigo under Linux, we can score 3.5 easily. Linux really does a much better job juggling the resources of the 2990WX. And again, with the split NUMA configuration, it is unusual. You could watch our NUMA video on that to learn a little bit more. It's an epic processor that looks like a desktop. But more importantly, for power users like Linus Torvalds that are doing super high-end software development, that are creating our world, they want a machine that works great and just gets out of the way. It doesn't need to be RGB, but it does need to be insane. This is an insane build. Now, one thing with our extreme system for Linus Torvalds is he's not gonna wanna rice it out, or I don't know, can you say that? I don't mean that to be in any kind of offensive term. But it's no RGB. There's not like, we haven't done any, we haven't brutalized this machine. It is a machine built to do work, to get out of the way and just be awesome. But I am a little bit curious about overclocking it. And overclocking it, I think, like just setting the voltage and the clock speed, that's way too ham-fisted. Precision Boost Overdrive is a beautiful, beautiful piece of technology. So the overclock here is really about Precision Boost Overdrive. And at what point does our quiet fan setup no longer work? Well, experimentally, it's around 325 watts. So TDP design, it's about 250 watts. At about 325 watts, we run into a little bit of a heat problem in this configuration. And it's not with the processor, it's with the motherboard. The VRMs get a little warm, even though the VRMs have active cooling. There's two fans built in for the VRM. And even though the VRM heatsink setup with the fins is basically one of the best ones of this generation of Threadripper motherboards, it still is a little bit too much to keep up for a long period of time, like over an hour of benchmarking, rendering benchmarks and compile benchmarks and things like that. And when the VRM overheats, the system will throttle. It'll throttle back and you'll lose a little bit of performance. And the goal here is to have ridiculous, insane performance with an overclock. And so what do? You do what any great software developer would do, and you fork it. The difference between a score of about 3 and 3.5 after an hour of grueling burn-in torture testing is our great value forks box. What is it? Well, this is what I was using to prototype a ducted air solution. So basically all this is a duct to force air to flow the way that I want it to flow. And so using that ducted the air over the VRM and RAM area so that the fans would get a little bit more breathing than they normally would. And that made the difference between 3 and 3.5 without me having to add another fan. Now, optionally, you could add another fan. You could pop the top and put another fan here and not have to mess with this. You could also add another small fan, like I've got this really super quiet Noctua fan, and you could just, put this in the top of the case or whatever so that it's also blowing back. I mean, even mounting it here would do the job, just so there's a little bit more airflow. But as it is, for overclocking, only 325 watts and above in this fan configuration will your VRMs throttle, and that's only after about an hour or so. And probably, you can push it probably a little bit beyond 325 watts, but maybe, don't quote me on that. So, sort of interesting, I think. But in doing that, I was able to push this whole setup to over 400 watts, something like 425 watts. But I was able to do that and keep the CPU temperature under 68 degrees C. So 68 degrees C is sort of the max temperature that you want to run Threadripper at, and I have a feeling that's because of the different dies and the different package, so there'll be different thermal properties of the different dies, and you don't want it to fail prematurely or something because of like heat expansion and contraction, and I don't know, 68 degrees C is not that hot for a piece of silicon, so you have to do a fair bit of work to keep it cool, and this cooling setup does that. At 425 watts, this cooling setup for the CPU can keep it cool. So there you have it, Linus Torvalds' dream build. Now, the catch is, Linus Torvalds doesn't know about that unless he's watching the video, in which case, hi, how's it going? Big fan. Want a computer? Yeah, so I haven't talked to Linus Torvalds, but I built Eric Raymond's machine. Maybe Eric Raymond can put in a good word, or maybe Eric Raymond's cat, because Eric Raymond's cat is really who pulls all the punches and the strings, and that's who I take orders from. Now this machine is a beauty of a machine. And I know Linus Torvalds is taking a little bit of a break right now, but when he returns, I hope that the tough love returns with him. This machine will be waiting on him for his return. Just, reach out, say hey to Level 1, shoot me an email, literally anything, and I would be glad to do whatever to set you up. Here's hoping you're back in action soon, Mr. Torvalds. We'll work out the logistics of that. But if for some reason Linus Torvalds doesn't want the system, I have a feeling it's going to Eric Raymond. Or maybe one will go to Linus Torvalds and one will go to Eric Raymond. I don't know. Level 1's gonna work out the details there, because Level 1 paid for most of this, but I reached out to Gigabyte and I said, hey, I'm really impressed with the Aorus Extreme. I wanna do something crazy. And they said, all right, sounds good. And the 2990WX is retail from Amazon. But Gigabyte said, you know what, we'll buy that for your project. It's fine, because we're probably gonna end up giving it away and it's gonna be, some crazy stuff. Reached out to Noctua. Thank you, Noctua. Thank you, Gigabyte, for supplying the parts and stuff for this. Pretty much everything else came from Level 1. So thanks, Level 1, should be good. We did use a Seasonic power supply. There's actually Seasonic power supplies in all three of these. Seasonic sent us a 1000 watt power supply to use, but we're so impressed with it, we bought another one. That's just how we roll. This is the Fractal Define R6, but this is also the gunmetal version of the Fractal Define R6. And they always like to, you know, Fractal Josh is like, oh, let's show off the case. And it's like, let's get what's on sale at Newegg. Oh, he's gonna kill me. I'm Wendell, I'm signing out, and I can find you in the level 1. You can find me in the level 1 forums. If you wanna know why I picked a particular component over any other particular component, be glad to chat with you about it in the level 1 forums. I'm Wendell, I'm signing out, and I'll see you there. Oh, and these systems are gonna be making some appearances in quite a few more videos. Another video coming up you can look forward to is the ECC 2666 versus the 2933 rated Threadripper certified G-Skill nice memory 2933 for Threadripper. So this has got all the performance points. This has got all the stability points. 128 gigs head to head, dual channel, dual rank, well, quad channel, 2 sticks of memory per channel, dual rank, because that's how you got to roll. So that's something you can look forward to. I'm Wendell, I'm signing out. I'm so excited. This is so much horsepower. It's a cluster of Threadrippers. It's a quorum of Threadrippers, Council of Ricks, Council of Threadrippers, cluster of Threadrippers. All right, I'm out. This machine is beastly, and I'm gonna be using it to do lots of terrible, terrible things like compile the kernel and Android and other sorts of benchmarking and who knows what else. So I guess it would be permissible just this one time to resume the RGB. Because RGB party time? It's party on the outside, not on the inside. All business inside. But we can occasionally do the RGB party here at level 1. I don't know. I'm so awkward. I'm Wendell, I'm signing out. You can find me in the level 1 forums.